Hello everyone, in this video I will explain a non-uniform quantization. I hope you all are familiar with uniform quantizer. In uniform quantizer, the step size is constant. So by determining only a step size, you can find out the decision boundaries for a quantizer because the step size is constant in uniform quantizer. Now consider some input source that generate more values near origin. So input is more likely to fall in the inner levels of the quantizer. For example, consider some input source that generates more values in the interval 0 to 1 and less number of values in the outer intervals, for example 5 to 10. If we use uniform quantizer for this particular input source, then average distortion will be large. In order to decrease the average distortion, we can try one solution. That is to approximate input better in high probability regions but at the cost of worst approximation in lower probability regions. Now, how we can do this? We can do this by making intervals smaller in regions that have more probability mass. Means if the input source generates most of the values near origin, then we would have smaller intervals near origin. Now, if we wanted to keep the number of intervals constant, then we would have larger intervals away from the origin. As you can see here, the input generates most of the values near origin, so near the origin the intervals are smaller, but far from the origin the intervals are larger. Why? Because we wanted to keep the number of intervals constant. So the quantizer that has non-uniform intervals is called a non-uniform quantizer. Means in non-uniform quantizer the step size is not constant. In uniform quantizer the step size is constant, but in non-uniform quantizer the step size is not constant. Now intervals that are closer to the origin are smaller, right, in the non-uniform quantizer. So the maximum value that the quantizer error can take place is also smaller. So it results in better approximation. Suppose near origin the interval size is 1. So for the interval 0 to 1, this interval 0 to 1, the output of the quantizer is 0.5. So the maximum error for this particular interval 0 to 1 is also 0.5. This is the case for the intervals near origin. Now intervals that are far from origin are larger. So maximum value that the error can take place is also larger. Suppose for example far from the origin the interval size is 5. Consider this particular interval 5 to 10. Here the step size is 5. The output of this interval is 7.5. So the maximum value for the error in this interval 5 to 10 is 2.5. So you can say that near origin the intervals are smaller, so the value for the error is also smaller, but far from the origin the intervals are larger, so the value for the quantizer error is bigger. But here our source is such that probability of getting smaller input values is much larger than getting larger signal values. So on the average the distortion will be lower as compared to uniform quantizer. So basic idea of non-uniform quantizer is to find the decision boundaries and reconstruction levels that minimize mean squared quantization error. There are two types of non-uniform quantizer. One is PDF optimized quantizer and another is compounded quantizer. So I hope you have understood. Thank you.